Here, good evening. I am G. Kiran Kumar, working as a lecturer in Electrical and Electronics Engineering, Institute Government College in Yadargutta. Today I am teaching the subject Basic Electrical Engineering for the first year, first sem. Subject code 18E105C. Topic Series and Parallel Resistance Circuits. Subtopic Problems on Series and Parallel Combination. So here again we studied the series. In the case of series circuit here, the resistance is nothing but the where three resistors are connected in the series, we can derive that is nothing but total R is equal to R1 plus R2 plus R3. In the case of parallel, where two or more resistors are connected in the parallel, total R is equal to, we can add here or 1 by R, R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1 plus R3 R1. So where in the case of series resistance circuits, the current remains the same and the voltage can be divided. Again, the case of parallel circuit, again the current can be divided and the voltage remains the same here. Now we see the problems on series and parallel combination. In the previous period we have discussed the problems on series and parallel combination circuits. On the completion of this period we would be able to solve problems on current division in parallel circuits. Again here, find the current in each branch of the circuit given below. The two resistors are connected in the parallel, where the 7 ohms resistor is connected in series with these two parallel resistors, where the voltage can be applied, the current can be flows. Again here we can write the formula nothing but the I1 is equal to I into R2 by R1 plus R2. Then we can also nothing but the I2 is equal to R3 by R1 by R1 plus R2 into A. So here given the two resistors 2.8 and 3 ohms are connected in the parallel. First we have to find out that is the combined resistance, that is R equivalent resistance. So these R equivalent resistance comes in series with the 7 ohms resistor. So we can find nothing but it is nothing but the R equivalent, which is equal to 2.8 into 3 by 2.8 plus 3. That is the two resistors are connected in parallel. The parallel combination comes in series with the 7 ohms resistance. Again given data here, R1 is equal to 2.8 ohms, R2 is equal to 3 ohms, R3 is equal to 7 ohms, V is equal to 6 volts. So I1, I2, I is equal to how much? Equivalent resistance of the parallel branch, that we can see RAB, that is the across the R and A and B, the 2 ohms, the two resistors are connected in the parallel. So that which is equal to RAB is equal to 2.7, that is which is nothing but the again which is equal to 2.8 into 3 divided by 2.8 plus 3. So which is equal to 1.45 ohms. The resistance of the combination circuit RAC is equal to 1.45 plus 7, which is equal to 8.45 ohms. The total or the current in 7 ohms, which is equal to I is equal to V by RAC, is equal to 6 by 8.45, which is equal to 0.71 amperes. So current in 2.8 ohms is I1 is equal to I into R2 by R1 plus R2, that is again which is equal to 0.71, R2 is equal to 3 divided by 2.8 plus 3. Then I2 current in 3 ohm resistor, that is nothing but I2, which is equal to I into R1 by R1 plus R2, which is equal to 0.71 into 2.8 by 2.8 plus 3, which is equal to 0.343 amperes. So again in the circuit given below, calculate the current in each resistor and total current, which is equal to again given 3 ohms and 6 ohms are connected in the parallel. The parallel combination is comes in series with the 8 ohms. Again we have to find out the two resistors are connected in the series. This combination comes in parallel with the 10 ohms resistor. Again here resistance between A and B is RAB is equal to 3 into 6 by 3 plus 6, which is equal to 18 by 9, which is equal to 2 ohms. That is equal. Now the given circuit as can be written as follows, where the 2 ohms and 8 ohms are connected in the again series. Again we have to add, that is nothing but RAC, which is equal to 2 plus 8, that is equal to 10 ohms. 10 ohms and 10 ohms is connected in parallel. Again we have to do the parallel combination. Resistance of branch ABC is equal to 2 plus 8 is equal to 10 ohms. Now 10 ohms and 10 ohms are in parallel, therefore RAC is equal to 10 into 10 by 10 plus 10, which is equal to 5 ohms. Total current I is equal to 30 by RAC, which is equal to 30 by 5, which is equal to 6 amperes. Again, current at A divides equally. Current through 10 ohms resistor is equal to 3 amperes. Current through 8 ohms resistor is 3 amperes. So current through 3 ohms resistor is equal to 3 into 6 by 3 plus 6 is equal to 2 amperes. Current through 6 ohms resistor, that is equal to 3 into 3 by 3 plus 6, which is equal to 1 ampere. Find the current through each resistance of the circuit. Again given here, first again we have to again find out the equivalent resistance. 7 ohms and 8 ohms are connected in the again parallel, and again we have to find out the one resistance. Again next we have to do 6 ohms, 4 ohms and 3 ohms are connected in the parallel. Again we have to find the equivalent resistance. Again this RAB resistance and RBC resistance and RCD resistance are connected in the series. So therefore we have to add all the resistance. Again we have to find the each branch, that we have to find the current I1, I2, I3, I4 and I5. So resistance between R and B, that is equal to 7 into 8 by 7 plus 5, again which is equal to 4.67 ohms. Again resistance between B and C, that is a 6 into 3 into 4 divided by 6 into 3 plus 3 into 4 plus 4 into 6, which is equal to 7 to 2 by 18 plus 12 plus 24, is equal to 1.33 ohms. So total resistance of the circuit between A and C is, which is equal to 4.67 plus 1.33 plus 9, which is equal to 15 ohms. Again current flows through the circuit, which is equal to, again here I is equal to 12 by 15, which is equal to 0.8 amperes. Again current through 9 ohms resistor, which is equal to 0.8 amperes. Current through 7 ohms resistor, which is equal to 0.8 into 8 by 7 plus 8, again which is equal to 0.427 ohms. Current through 8 ohm resistor, which is equal to 0.8 plus into 7 by 7 plus 8, which is equal to 0.373 ohms. Current through 6 ohm resistor is 0.8. Again the 3 ohms resistor connected in the again here parallel, that is a 4 into 3 divided by 6 into 4 plus 4 into 3 plus again 3 into 6, 0.8 into 12 by 54, that is which is equal to 0.178 amperes. Again current through 4 ohm resistor is 0.8 into 6 into 4 divided by 54, 0.355 amperes. Current through 3 ohm resistor, which is equal to 0.8 to 6 into 3 by 54, which is equal to 0.267 amperes. So in this period we have discussed how to solve problems to solve parallel circuit by applying current division formula. And in the case of two parallel branch parallel circuit, if one of the resistor gets short circuited, then the voltage across the second resistor is 0, the voltage across the first resistor is 0, both A and B none, both A and B. Find the current in each branch of the circuit given below. So first we have to do, that is nothing but RAB, which is equal to 14 into 16 divided by 14 plus 16, and we get some value. Again next we have to do RBC, which is equal to 12 into 18 into 6 divided by 12 into 8 plus 6 into 8 plus 12 into 6. Again we get RBC value. So again next we have to connect RAB, RBC and RCD are in series. Again we have to add all the three resistance. Again we have to find the current across each resistance. Again we have to find the value of I. I is equal to V by R. So again we have to find the current through 14 ohms resistor, current through 16 ohms resistor, current through 2 ohms resistor, current through 8 ohms resistor, current through 6 ohms resistor. Next here topic work, power and energy. Again subtopic prefix for SI units and work, power and energy. Again in the case of work, again in the case of electricals, again here systems here, the work can be done in the case of electrical is nothing but the by passing the current through the again conductor, some work can be done. The power is nothing but the amount of the work done in the electrical systems is nothing but the again power. The power can also be defined as the product of the voltage to current. Energy is nothing but the total amount of the entire total amount of the work done in the case of electrical again systems is nothing but the energy here. So now we see the prefix for SI units of the work, power and energy. In the previous period we have discussed problems on series and parallel combination circuits. On completion of this topic you would be able to know prefix of SI units, correct use of symbols for SI units, work as electrical quantity, work as thermal quantity, factor prefix symbol 10 to the power of 24, that is the iota. You can say symbol is nothing but the Y. To the power of 21 nothing but a zeta, symbol is Z. 10 to the power of 18 is nothing but the exa, E. 10 to the power of 15 is nothing but the peta, P. 10 to the power of 12 is nothing but the tera, nothing but the T here. 10 to the power of 9 is nothing but the giga, that is nothing but G. 10 to the power of 6 is nothing but the mega, nothing but the M. 10 to the power of 3 is nothing but the kilo, nothing but the K. 10 square is nothing but the hectare, nothing but the H. 10 to the power of 1 is nothing but the deca, nothing but the TA. 10 to the power of minus 1 is nothing but the decimal, that is the T. 10 to the power of minus 2 nothing but the centi, nothing but the C. 10 to the power of minus 3 nothing but the milli, that is the M. 10 to the power of minus 6 that is nothing but the micro, that is the 1. 10 to the power of minus 9 that is nothing but the nano, that is the N. So again we can also write that is nothing but the 1 micro ohms, which is equal to 1 into 10 to the power of minus 6. 1 nano, which is equal to 1 into 10 to the power of minus 9. Ten to the power of minus 12 that is nothing but the pico, P. 10 to the power of minus 15 that is nothing but the femto, that is F. 10 to the power of minus 18 that is nothing but the atto, that is A. 10 to the power of minus 21 that is nothing but the zepto, Z. 10 to the power of minus 24 that is the yocto, Z. So correct use of symbols for SI units. While writing an SI unit in full, do not start with capital letter, but if the unit is named after a person, the symbol for a unit must be a capital letter. So, example correct, incorrect. Joule, Joule, J. Newton, Newton. Meter, meter. Hertz, Hertz. So again correct example is nothing but the joule. Again it is nothing but the again here again unit, SI unit, units of the again joules, coulombs. newtons, that is the force, meters, 1 meter, hertz, that is nothing but the frequency. So first we have to write with the small letters, not with the capital letters here. Use no plurals for SI units. Example, 10 newton, 10 newtons, 10 newtons, ns. It is not the correct. 2 kilograms, 2 kilograms, 2 kgs is incorrect. 5 seconds, seconds, yes, 5 seconds. Use proper spacing between numerals and symbols or between two symbols. Example, 15 newton meter, 15 newton meter, incorrect. So we have to give the gap between them, or we can write also nothing but the so that we can write it as a 15 newton meter. It is also correct. So don't use space between prefix and symbol of the unit. That is the example, 5 milliamperes, 5 milliamperes, incorrect. 5 milliamps. 10 kilowatts, 10 kilowatts, that is a 10 kW. Force, it is the product of mass and the acceleration. F is equal to ma. If m is equal to kg, a is equal to 1 meter per second square, then F is equal to 1 newton. 1 newton is that force which can give an acceleration of 1 meter per second square to the mass of 1 kg. Gravitational unit of force is kg weight. The force with which a body is attracted towards the center of the earth is called the weight of the body. If m is the mass of the body in kg and g is the acceleration due to gravity in meter per second square. The force with the body is attracted towards the center of that is called the weight of the body. Again we can determine again weight of the body is nothing but the measuring force. If m is the mass of the body in kg and g is the acceleration due to gravity, that is the meter per second square, the weight v mg newtons. 1 kg weight means 1 mass of 1 kg. So 1 kg weight we can write it as a 1 kg here. So that is 9.81 into 1, that is the 9.81 newtons. The current may be defined as the rate at which the electrons flow or moving along the wire gives the current here. Simple. Again we can define it nothing but the, again it is nothing but the wire where we are applying the voltage. Again here the current can be flows by applying the voltage. Here the electrons can be again extract all along the length of the conductor. So it is represented by the letter I and it's measured in amperes. Again it is nothing but the, again we are determining nothing but the here the current. Again the conductor can be moves in between the two poles. Again this principle can be exerted in the case of again generators. We can say it is nothing but the moving coil instrument here. So here N and S we can say these are nothing but the electromagnets. Again in between them it is moving, it's nothing but the conductor. Again the two ends of the conductor will be connected with the two slip rings. Again this is nothing but the AC generator which can be moved here. Again this can be shows is nothing but the again where that battery can be connected, DC supply, while the generator can be low. Again the electron can be flows here from the positive to negative. Again the bulb can be glow. Again the work in progress. Again here we are seeing that is a man. Again he can do the work, he doing the work here. Work is said to be done on a body when the force acts on it and the body moves through some distance. The SI unit of the work or energy is nothing but the joules here. Again this work we can say nothing but the mechanical work we can say here. The work acts on the body to move the body through some distance. Is nothing but the work here. The SI unit of the work in our energy is nothing but the joules, that is Newton meter or calories here. Energy, it is defined as the capacity to do work or the entire amount of the work done. In the case of again electrical system is nothing but the energy. The units are same as work, joules, Newton meter or kilowatt hour or calories. Power is said to be the rate of doing work is called as the power. Rate of doing work is called as the power. The power can also be defined as the nothing but the again P is equal to VI. Product of the voltage and the current measured in watts. Power can measure in watts here. Again also called as the work done per unit time or work done by time taken. Work done by time taken. The unit of the power is joules per second, Newton meter per second or watt. Work in the mechanical system we can define. The work is said to be done on a body when the force acts on it and the body moves through some distance. This work done is stored in the body in the form of energy here. Taking example is nothing but the again car or a bike or any here mechanical mechanical body here. When the force acts on the body to move the body through some distance is called as a mechanical work. Work and energy are measured in same units, that is SI unit of the work or energy in the joules or Newton meters. Again we can say the work done on a body is 1 joule if the force of 1 newtons moves the body through 1 meter in the direction of the force. So when the force F Newton exerted on the body through a distance d meters in the direction of the force, work done is equal to force into distance. Equal to, suppose a force of F Newton is maintained tangential at a radius r meter from 0. If 1 revolution the point of application of force travels through a distance of 2 pi r meters. One revolution the point of application of force travels through a distance of 2 pi r meter, that is nothing but the again we can it is nothing but the again r radius or distance d here measured in meters. And work done in 1 revolution, which is called force into distance moved in 1 revolution here. That force into distance we can say 2 pi r, 2 pi t, that is the joules, t we can say F into r, joules or Newton meters. So work done can be measured in joules or Newton meters, where t is equal to F into r and is the torque here. It is nothing but the force. If the body make n revolution per minute, then work done in a minute is equal to 2 pi nt joules. Sir, a mass of 100 kg is raised by the means of rope passing through a pulley wheel of 0.5 diameter. Calculate the work done when the pulley makes 50 revolutions. So given data is nothing but the mass, that is the 1 kg raised by the means of rope passing around a pulley wheel of diameter. Calculate the work done when pulley makes 50 revolutions. That given data mass is equal to again 100 kg. Mass is equal to 100 kg. Diameter of the wheel is equal to 0.8 meters. Number of revolutions n is equal to 50. The work done W is equal to how much? It is the formula required for work done is equal to force into distance. So F is equal to m into g, that is the 2 pi r into n. D is equal to 2 pi r into n. That is F is equal to mg, that is 100 into 9.81 converted to newtons. Then you get 981 newtons. Radius r is equal to 0.5 by 2, which is equal to 0.25 meters. Distance covered in n revolutions is equal to 2 pi r into n. 2 pi into 0.25 into 50, which is equal to 78.54 again meters. Total work done is equal to F into D joules, which is equal to 981 into 78.54, which is equal to 77 again 77,047.74 joules. Work done is equal to 77047.74 joules. Again, work. Electrical work is said to be done in an electrical circuit when Q ampere second of electricity passes through a circuit against the potential difference of V volt. Work done is equal to V into Q, which is equal to VIT watt second. The practical unit of the work is kilowatt hour. 1 unit is equal to 1 kilowatt hour. That is again 1 kilo is nothing but the 1000 watt hour. Again 1660 watts second here measuring. It is equal to 36 into 10 to the power of 5 watts second. 1 unit. 1 kilowatt hour is equal to 36 into 10 to the power of 5 watts second here. So thermal work is said to be done by the current passing through the heater coil against the applied voltage, and heat is produced. It is measured in calories or kilocalories. So we can also say here, again, whenever the current passes through the coil, some heat can be produced and some work can be done. So it is measured in calories or kilocalories. So example, heater, that is again nothing but the heating element, again here, again, or oven we can say here. Work units relation between mechanical, electrical and thermal. 1 joule, 1 Newton meter is equal to 1 watt second, which is equal to 0.2392 calories. So an electrical bulb marked as 60 watts is connected to a voltage of 230 volts. Determine the current drawn by the bulb and the resistance of its filament. Also calculate the energy consumed if the bulb is used in day for 6 hours time. So we know that P is equal to V into I. P is equal to 60 watts and V is equal to 230 volts. Substituting the values in the powers expression. 60 is equal to 230 into I. So that I is equal to 60 by 230 is equal to 0.26087 ampere. So we know power equation, that is the power can be defined as the product of voltage to current. Power given 60 watts and the voltage is given 230 volts. Substitute the values again, we get I is equal to 0.26087 amperes. So from Ohm's law we know that R is equal to V by I. Resistance of the filament of the bulb is equal to 230 by 0.26087, 881.67 ohms. Energy is equal to power into time is equal to 60 into 6 by 1000. .36 kilowatt hour. So we have discussed prefix of SI units, correct use of symbols for SI units. We have discussed about definitions of SI unit, work mechanical form, solve problems, work as electrical quantity, work as thermal quantity. So which of the following correct use of a symbol for SI unit? 10 Newton meter, 15 Newton meter, 20 Newton meter, none of the above. These are 15 Newton meters. The value of mega is 10 to the power of 12, 10 to the power of 3, 10 to the power of 6, 10 to the power of minus 6, 10 to the power of 6. The value of pico is 10 to the power of minus 9, 10 to the power of minus 12, 10 to the power of minus 3, 10 to the power of minus 6. It is 10 to the power of minus 12. The value of micro is 10 to the power of minus 6, 10 to the power of minus 2, 10 to the power of 12, 10 to the power of 9, 10 to the power of minus 6. Value of nano is 10 to the power of 6, 10 to the power of 12, 10 to the power of minus 3, 10 to the power of minus 9, 10 to the power of minus 9. Unit of electrical work watts, calories, watt second, joules, watt second. Unit of heat is watts, calories, watt second, joules, calories. Frequency of questions are define mechanical work, define electrical work and mention the units, define the thermal work and mention the unit, define electrical energy and mention the unit. Okay, thank you.